Hey guys, my name is Tensor. Welcome to the first video in my Beginner's Dart tutorial series. I decided to do this beginner series on Dart because I found that there aren't many good resources for learning Dart without having to have any kind of prior knowledge with some kind of programming language like JavaScript, C#, or Java. So while this series will be a bit accelerated, it should help people who want to learn Dart as their first programming language. To be able to follow along with this series, you're going to need to install Dart. So go over to dartlang.org and then click on the button that says Install Dart. You'll see here that you have three different choices. You have Flutter, which will get you the Flutter SDK and a version of Dart that goes along with it. And then you have Web and Server. I recommend you just click on Server in this case. When you've done that, you'll get some instructions for Windows, Linux, and Mac, depending on the operating system that you're using, on how to install Dart. If you're using Windows, I do recommend that you use the Setup Wizard. Another alternative is to use the Scoop command line package manager, and you can go and get this from scoop.sh. I find that Scoop's a lot faster and a lot more lightweight than Chocolatey, and it's a lot easier to deal with, and it feels more like a Linux package manager than Chocolatey does. Once you have Dart installed on your machine, you can go into a command line and type in dart -- version to see if you have access to the Dart virtual machine. And you can see here I get back the version number for the virtual machine that's currently installed on my computer. You also should check to see if you have the pub tool installed properly. So go ahead and run pub version, and this should give you back a version for the pub tool as well. In this particular video, we won't get into the pub tool, but just keep in mind that it's the main package manager for Dart. To get started learning about the language, I created a folder, and then inside of it I just created a main.dart file, and inside of here I've created a main function. To show you that I can actually run this file, I'm just going to construct a hello world program. So I'm just going to type in print and then pass in a string that says hello, world. And then to execute the program, I just need to type in Dart followed by main.dart. And as you can see, it prints out the words hello, world. For those of you who are completely new to programming, this main function here is essentially the entry point for our program. This means that when we are executing the program, the things that appear inside of the main function get executed in order. So for instance, if I create two print statements, and the first one says hi, and then the second one says from Dart ! If I execute this code, the first print statement will execute first, and then the second print statement will execute second. And as you would expect, it would say hi, and then go to a new line, and then say from Dart. This style of programming is what is called imperative programming. Imperative programming is essentially a programming paradigm wherein you write a set of instructions that execute in a sequential order. So in this case, I've created a program that will go first and print out the word hi, and then move on to the next line and then print out the words from Dart. Inside of the Dart programming language, everything that you can put inside of a variable is an object, and every object is an instance of what's called a class. This is something that you just need to kind of keep in mind in the back of your head for now, because we're not going to be really looking at classes until a later video. Here's an example of how, for instance, numbers in Dart are objects. So here I've created a variable declaration, and I'm binding that variable x to the value of -10. So the keyword var allows me to define x as a variable, and then the equal sign allows me to take anything that's on the right-hand side and bind it to this value of x. Then when I go to print out x, it will take the value that's inside of this variable and print it out. And predictably, this will just print out -10. To demonstrate to you guys that the value of -10 is actually an object, I can put a little period next to it, and then I'll get a list of methods that I can execute on the -10, and these methods are a part of the quote-unquote integer class type. So for instance, say I want to get the absolute value of -10, I can execute this method .abs on -10, and this should give us back a +10. We can call this absolute value method on x inside of the print statement, and this way we know that now when this prints out it will give us a +10. And as you can see here, that is indeed the case. The core Dart language has 7 main types built inside of it. These are 7 main primitive object types. So rather than using var, I can use the type name followed by the variable name to create a variable. So in this case, I'm creating an integer and a double, and the integer is called x and the double is called y. And I'm binding the integer x to 10 and the double y to 10.0. For the string type, I can create a string by using the uppercase string type. This is a convention that has sort of followed from Java and other C-like languages. So my string S is using what's called string interpolation, where we can insert code into the string and get the resulting value from this code as the string itself. So what's happening here is we're taking the integer x and the double y, and we're adding them together, and then the result of this operator will be pushed into the value of s as a string. We can go ahead and define a boolean. So here I've defined a boolean b as true. Booleans can either be true or false, and that's it. They're literally just binary types. We can also create the list, and if we want to create a list where we don't have to define the actual type inside of it, we can just say list. So in this case, I'm creating a list L of integer type, but I'm not specifically stating that there are integers in the list. Whereas down here, I'm creating a list of string type, and I am specifically stating that there are strings inside of this list. Now I've put some print statements into this code. So we're going to print out the string here, which is the addition of this number with this number. And we're also going to print out the boolean. Then with the list, we're going to print out the 0th index, meaning the first value of the list, because lists inside of Dart are what are called 0 indexed. This means that when you count from the beginning of the list, you count from 0. So the number 1 is the 0th indexed, the number 2 is the first index, and the number 3 is the second index. And we can access it using these square brackets like this. So I can say, okay, well, I want the number 1 out of this list. So I'm going to say, okay, get the 0th index of list L, and this will give us back 1. Now down here with ls, I want to get the number 2, so I am going to pass in the first index of ls. And of course, here we get all of the results. We added an integer and a double, and we put it into a string. And of course, we get a double if we add an integer and a double with Dart. Now let's take a look at a hash map. So I've created a map here where we have keys that are strings, where the first key is A, the second key is B, and the third key is C. And then our values are integers. I can, of course, like our list, just put the type map on the variable, or I can explicitly add the type to the map type. So the key type will be string, and then the value type will be an integer. Again, like with our lists, we can access the values inside of our map using square brackets. But in this case, rather than using normal indexes, we can just use the keys to get the values out. So I'm getting out the value of 10, so I'm going to pass in the string A. As you can see here, I'm using single quotes inside of the map. These are still strings, and this here is the same as this inside of Dart. We got 10 out of our map, and we were able to print it to our console. In this video, I'm going to ignore runes and symbols for now. I'm doing this mainly because runes are not very important. They're pretty niche, and you won't really encounter them until you get all the way into Flutter. And then symbols, they are not really used that heavily in this language. One of the consequences of having everything inside of Dart be an object is that functions are also objects, and as a result they're also what are called first-class functions, which means that they're first-class citizens inside of the language. This means that the function can be named by a variable, it can be passed as an argument to another function, it can be returned as a result from a function, and it can be stored in data structures and created in any scope. I know some of that is going to sound like gibberish if you're just starting with this video, but it will make more sense as we go through the series. Here I've created a basic addition function. This addition function returns an integer, and then inside of the add function, we take in what are called two parameters. In this case, both of them are integers. So integer a and integer b go into this function, and then we return the result of adding a and b together. It is, of course, perfectly acceptable to write your function like this with no type declarations, because Dart will be able to infer the types from your function. However, doing it this way will make the compiler work a little bit harder, and I highly recommend that you get into the habit of writing the types out for every variable that you create inside of Dart. If I hover over the function, you can see here it says that it takes in a dynamic A and a dynamic B, and then it returns a dynamic from the function. To kind of display my point, I've invoked this add function 4 different times inside of print statements. I'm adding together 2 integers, then I'm adding together 2 doubles, then I'm adding together 2 strings, and I'm adding together 2 booleans. If we go to run this inside of our command line, you can see here that the integers add together, the doubles add together, and even the strings add together, but the booleans do not add together because they do not have a addition method attached to them. And actually, if I change this from addition to multiplication, then even the strings won't work because the strings can't be augmented by the multiplication symbol. So usually it's easier just to add the type annotations to your functions, just to make sure that you get the appropriate information into the function and you get a predictable set of behavior. Getting back to how functions are objects, we can define a variable up here outside of our main function and outside of the add function. This makes this variable global, meaning that it can be accessed by any of the functions. So down inside of our main function, we take this global function variable and we assign it to the add function that we've created up here. Then we can say var result equals the execution of function when we pass in 20 and 30. If you look at where we pass add into the fun variable, we do not have parentheses after the add call, so add will not be executed directly here. But add does get executed right here. So essentially what happens is we take the add function, we put a reference of it into this fun variable, and then we can execute the add function through this fun reference by calling it with parentheses right here. And the result of the preceding code is right here. We can also pass functions to other functions. So for instance, we have our add function again, and then we have a function called exec, and this function takes in a function type and then a dynamic x and y. And then what it does is it returns the execution of the op function with x and y inside of it. So inside of main, we can then call exec, pass in add for op, 20 for x, and then 30 for y. And then when we print this out, it will print out 50. And like before, we get the result is 50 because we're still adding together 20 and 30. Because both x and y are dynamic, the exec function can literally just take in any other global function that takes in 2 variables and execute it for us. And there are various reasons why we would want to do this, but for now, just keep in mind that you're able to pass functions to other functions in this way. We can also return functions from other functions, and for this I've actually created 2 functions at the top. including our original add function as well as a subtract function called sub. Now notice that these two functions are written in a different format than how I was writing them before. You can do this as a shorthand for single line functions. So in this case, our add function is still taking x and y and then adding them together and returning them from the function, but we don't have to write the keyword return, nor do we have to put in the curly brackets if we just use a equal and then a greater than sign. And as you can see here, it's just an equal and a greater than sign. I've just got code ligatures turned on so it looks like an arrow. The same is true for the sub function, where we're taking in x and y, and then we're just subtracting the two and returning the result. Down here, we've got a choose function, which takes in a boolean, and if that boolean value is equal to true, and this is a double equal sign, then we'll return the function add, otherwise we'll return the function subtract. So now down in main, we can call choose with true inside of it, which will give us back the add function. And in our print statement, we then need to execute this add function by using the parentheses on result and passing in the two arguments that we want to add together. So in our string interpolation, we can just write result and then put in our parentheses and then put in 40 and 50. And this will add 40 and 50 together and then give us that back inside of our string. And predictably, we get the result is 90. It's also fairly interesting to note that you can add a second pair of parentheses to a function that returns a non-executed other function. So in this case, because we're returning a reference to add, we can then immediately execute add so that we can put the resulting value inside of our result variable. So choose goes out and it runs this function here, and then it gets back the reference to the returned function, and then we execute that returned function with 10 and 20 inside of it. And actually, I'll change the choose function's parameter to false so that we get back our subtraction function. And as you can see here, we get back result is -10 because it subtracted 10 from 20. I also mentioned that we can store functions inside of data types. In this case, I'm storing our two functions add and sub inside of a list called operators. And then down here inside of our main function, I can grab the sub function by calling the first index of operators. And then I can execute the sub function using the parentheses and passing in the two arguments. Again, we get back the result of -10. Now, before we close out of this video, I want to talk briefly about closures. Closures can be created like this, where we just have a set of parentheses followed by a equal and then a greater sign, followed by the line that we want to return from the function. In this case, we're not going to return anything. Instead, we're just going to execute a print statement. We can also make closures like this, where we just use those parentheses like before, and then we have a set of curly brackets. And in this case, we're also printing out hello from closure. And if we want to pass arguments to the closure, we put them into this parentheses. So for instance, we could pass in A and B, and then we could say add them together inside of our print statement like that. These functions are what are called anonymous functions because they don't have to have names. So this function is just the return statement of this calc function, and then this function, it was originally bound to a variable x, but now it doesn't need to be bound to any kind of variable at all. And in fact, if I want to execute it, I can follow the function declaration by a set of parentheses with the two arguments that I want to pass to it. Let's take a look at our calc function really quick. So we have a parameter that we pass into calc, and then calc has its own variable c, which is set equal to 1 by default. Then we return our closure, which prints out that the value is b plus c plus plus, and the plus plus here, what it does is it increments c by 1. So what happens is, when we call calc2, it returns our anonymous function where b is 2 and then c is 1. I can then go ahead and execute the anonymous function multiple times by calling f with parentheses after it. So here we have our first closure, which comes back and says hello from closure 30. And then we have our F closure, which comes back and says the value is 3, 4, and 5 because the C is being incremented each time we call to this function. Now I kind of want to demonstrate something here. So what I'm going to do is call to our calculate function with 10 inside of it, like we're doing here when we're assigning it to F, and then immediately execute it after our first call to the F function. Now, what do you think the value of C will be when we execute it this time with this call here? As we saw before, when we were executing F, it was incrementing each time we called to F because of this plus plus operator. Well, as you can see here, our first call to F gives us back 11, and then our call to Calc, where it's just immediately executing, also gives us back 11. And that's because when we call to Calc outside of F, we actually create another instance of this anonymous function, and that also includes another instance of the C variable, which means that it starts back at 1. This concept's important to understand because this is part of why you would use a closure in the first place, because you're able to essentially scope a variable to this function so that you know what that value will be when you execute the function. Anyway, guys, we'll touch on this concept a bit more as we go into classes and things like that, but I hope you found this tutorial useful. If you did, feel free to subscribe and like. If you have any questions or comments, feel free to leave them in the box below. And if you disliked this video, then by all means, downvote it as much as you like. Have a good night.